Okay, so continuing the same discussion that we had before, so basically we have basically in order to show that I of n is onto, so then you can simply show that for every y belonging to the codomain of this function, there exists an element x belonging to the domain of the function that can be used as a pre-image for that element, and that means that this function is basically onto, right? Now this function over here, the second function that we have, is what we want to show is that basically I of n plus I of n of x, we want to show that this function is not onto. We want to show that although I of n is onto, but I of n plus I of n from n to n, which is defined as this function here, is not onto. So to show that this is not onto, what you need to do is that let's see. Okay, so now in order to show that basically I of n plus I of n of x is not onto, there is an easy, well, in this particular case, there is an easy way to do it. Meaning that you can argue that, of course, you can see that basically the output of this function is 2x, meaning that it's a bunch of basically, it's a bunch of even numbers. So since you have a bunch of even numbers, if you have an odd number, for example, let's say 3, for example, a 3 is not basically through this function is not going to be mapped to anything. Because suppose that, for example, 2x is equal to 3, then x is equal to 3 divided by 2. And 3 divided by 2 does not belong to the domain of the function, because the domain of the function is a set of natural numbers. 3 divided by 2 is a rational number, it doesn't belong to the set of natural numbers. Or you can say that to make a better argument, you can say that basically clearly I of n is onto, but I of n plus I of n is not onto, as we can find an element 3 in the codomain n, as we can find an element 3 in the codomain n, such that there does not exist x in the domain n, such that there does not exist basically x in the domain n, with I of n plus I of n of x is equal to 2x is equal to 3, right? Or what you can do is that you can make another argument, which is basically my favorite type of argument, which is basically using that you can do a whole bunch of things. Meaning that you can say that basically let us take y as, you can say, let us take y as an arbitrary, as an arbitrary element of the range of f, of the range of basically, well, I of n plus I of n, we have no f here, of the range of I of n plus I of n. Now, for the sake of simplicity, what I'm going to do is that I'm going to basically say that I of n plus I of n of x, which is equal to 2x, and basically the domain is n and the range and the codomain is n. I'm going to regard this as a function like, for example, f of x is equal to 2x, and f goes from, for example, n to n, because this is not easy for me to talk about this function. It's a unusual, weird function, right? So let us take y as an arbitrary element of the range of f. So now I'm talking about this function, but actually these are actually the same functions. There is no difference. So which means that, now if that is the case, therefore you can say that therefore basically y is equal to f of x, because f of x is basically all of the elements in the range of your function, of course. Which means that if y is equal to f of x, then you can say that y is equal to f of x is equal to 2x, which means that y is equal to 2x, and then what that means is that x is equal to y divided by 2, right? Now over here we had f of x. Over here we had f of x is equal to 2x. Instead of x, if I write y divided by 2 and substitute that here as well, 2 times y divided by 2, I'll get a y, which means that f of y divided by 2, y being an arbitrary element of the range of the function f, is equal to y. Which means that every y that I choose in the range of the function f, there is some element y divided by 2 that takes me to that element, right? So now if I take y as, for example, some number as for example 3, right? The same example that we had here. So if I take y as 3, then y divided by 2, which is the element in the domain of the function which is supposed to take me there, is equal to 3 divided by 2, which does not belong to the domain of the function. And therefore the function is not onto, meaning that you can argue that, for example, 3 belongs to n, the codomain of the function, belongs to the codomain of the function, and in order to make sure that for example 3 belonging to n is the image of some element in the domain of the function, in the domain of the function, let us equate 3 to y. So if I write 3 is equal to y, then that means that then there must be some y divided by 2 based on this belonging to n, the domain of the function, which is the pre-image of 3 is equal to y. But basically y divided by 2 is equal to 3 divided by 2 does not belong to the set of natural numbers. Therefore 3 is not an image of any element in the domain of the function, in the domain of f, and therefore f is not onto, or it's not surjective. So that's basically all the different ways that you can talk about this. But then and I took a long time to talk about this example, but well, basically sometimes you get the chance to talk about a couple of things in the context of some example, which is of course very good, because some examples give you some context to basically talk about a couple of things. Otherwise there is no way to talk about them, and that's all basically all simply review. Now example number 51. Example number 51, you have consider a function f from an interval 0 to pi by 2, close interval of 0 pi by 2 to r, given by f of x is equal to sine x, and we have some other function g from 0 to pi by 2, and this is also a closed interval to r, given by g of x is equal to cos x. We want to show that f and g are 1, 1. We want to show that f and g are 1, 1, but f plus g is not 1, 1. That's also a good question. Okay, to solve this problem, basically first of all, you know that f of f, which is basically a function that goes from this interval to r, and which is basically f of x is equal to sine x, that is of course a 1, 1 function, of course, from this considering that you have this domain. And this is also a 1, 1 function considering that you have this domain g of x is equal to cos x. And of course you know that basically if you have basically f of x is equal to sine x, then you have, for example, you can go for example pi by 2, you can have pi over here, you have 3 pi by 2, and you have 2 pi, let's say this is 2 pi, And if you're plotting the function f of x is equal to sine x, what you will have is that, of course, you know that sine 0 is equal to 0. So sine 0 is equal to 0. So this is, let's say that this is 1 and negative 1. And sine basically pi by 2 is equal to 1. Sine pi is equal to 0. Sine 3 pi by 2 is equal to negative 1. And sine 2 pi is equal to 0. So you will get basically this, some function like this. Of course, it's not exactly symmetric, but that's the function that you would get. Now, of course, you can see that the function, so for example, if you go from 0 to 2 pi, the function is not 1, 1. Meaning that if the domain is limited to, for example, 0 to 2 pi, you can see that this output you could have it, you have the same output on these two points on the graph of the function, and you have the same output here and the same output here, but the x's are different, meaning that let's call this, for example, x1, and let's call this x2. Then you can say that f of x1 is equal to f of x2, and x1 is not equal to x2. That means that the function, if x basically belongs to, for example, the interval 0 to 2 pi, for example, and that means that f is not 1, 1. Now, on the other hand, if I limit myself to, for example, 0 to pi by 2, if x belongs to 0 to pi by 2, then you can see that the function is basically 1, 1 over here. The function is basically this function here, and there are no two, basically, for example, you can see that this output, for example, is mapped to this input, this output is mapped to this input, this output is mapped to this input, and this kind of situation never happens between 0 to pi by 2. And the same is true of basically g of x between 0 to pi by 2. Otherwise, if you make the domain a little bit different, then of course the function is not going to be 1, 1. Now, when you're talking about, so that means that f and g are simply 1, 1, provided that you have this domain, exactly this domain. Now, f plus g is basically, f plus g is different, meaning that I think if of course, assuming that I'm supposed to take to basically keep the same domain and codomain, let's say that f plus g is a function, let's say that it's a function that goes from 0 to pi by 2 to r. Then what happens is that, and f plus g of x is equal to sine x plus cos x, right? That is the same thing as f of x plus g of x, which is equal to sine x plus cos x. Now what happens is that if you plot this function, if you draw the graph of this function at 0, basically, let's say that you have your alpha here, some angle 0, for example, and pi by 2, 0 and pi by 2, and let's say that this is sine alpha and this is cos alpha. So what happens is that you can of course extend this table to 0 pi by 2, pi, 3 pi by 2, and 2 pi. And then what we have is that basically sine of 0 is equal to, is of course equal to 0. Cos of 0 is equal to 1. Sine pi by 2 is equal to 1, cos pi by 2 is equal to sine pi by 2 is equal to 1, cos pi by 2 is equal to 0. Sine pi is equal to 0, cos pi is equal to negative 1. Sine 3 pi by 2 is equal to negative 1, cos 3 pi by 2 is equal to 0. And sine 2 pi is equal to sine 0, which is equal to 0. And cos of 2 pi is equal to cos of 0, which is equal to 1. Which means that the output of this function would be these two numbers added together. So you would get basically at 0 your output is going to be 1. At, let's say that this is, for example, pi by 2. This is, for example, pi. This is 3 pi by 2, and this is 2 pi. So at 0 you're at 1, at pi by 2 you're at 1. That's a weird function. At pi you are at negative 1. At pi you're at negative 1. I don't know what happens halfway between these. And at 3 pi by 2 you're at negative 1. And at 2 pi you're at 1. Now let's see what happens, for example, between... Would be interesting to know what happens there, but it's not important right now. So what's important is that right now we are concerned about this interval in the domain of the function, which is basically 0 to pi by 2, right? So at basically at f of x is equal to, at f of x, for f of x is equal to 1, for f of x is equal to 1. Now if I say that in the case of this function, if I say that f of x1 is equal to f of x2 is equal to 1, then you can say that x1 is equal to, for example, 0, and x2 is equal to pi by 2, which means that x1 is not equal to x2, which means that basically the function f plus g is not 1, 1. Is not 1, 1. So, or as basically the way that they have written the solution here, what they have written is that for basically, since for any two distinct elements x1 and x2, since for any two distinct elements x1 and x2 in 0 to pi by 2, sine x1 is not equal to sine x2. Sine x1 is not equal to sine x2, and cos x1 is not equal to cos x2. Both f and g are must be 1, 1. F and g must be 1, 1. But f plus g of 0 is equal to sine 0 plus cos 0. Now sine 0 is equal to 0, cos 0 is equal to 1, so that is equal to 1, and f plus g of pi by 2, f plus g of pi by 2 is equal to sine pi by 2 plus cos pi by 2, which is equal to 1 plus 0, which is equal to 1. Therefore, f plus, so you can see that the outputs of the function are 1 and 1, but the inputs are not the same. Here the input is pi by 2, here is the input is 0, meaning that the inputs are different, but the outputs are the same. Therefore, f plus g is not 1, 1. Therefore, f plus g is not 1, 1. Okay, so now we are at the end of these exercises, the miscellaneous examples, and after this we have a whole bunch of exercises, 19 of them. We will go through those exercises as well in the next videos. I think it's going to be at least probably 5 to 6 videos to cover those as well. And so I'll see you in the next video, and thank you.